Hello everyone, here is a simple but very nice question. A rod is projected as shown. There is uniform gravitational field and air resistance is negligible. Starting from t is equal to 0, we have to find the number of the revolutions of this rod when it reaches back to its initial position. So I request you to post your opinion, your answer in the comment box, and I am proceeding with the solution. Suppose this is the rod having mass m, length L, and it is projected like this. If we draw the free body diagram of the rod, the only force acting is mg because air resistance is negligible and the rod is having uniform mass distribution. It means the center of mass of the rod will be lying at its center. So here we can see the torque about center of mass should be how much? 0, because the only force is mg, and since the gravitational field is uniform, so we can show that mg at the center of mass. If the torque about the center of mass is 0, it indicates that I about center of mass into alpha is the angular acceleration, this must be equal to 0. Since the moment of inertia of the rod about the center of mass is non-zero, this part is not equal to 0. It means alpha should be 0. And if alpha is 0, it indicates that the omega is constant. It means the angular velocity of the rod will remain constant. Then question becomes very simple. This omega will not change. Due to the effect of this omega, the rod will have the rotational motion. Got it? And due to this u, the rod will have the translational motion. Now you can treat it as a simple case of projectile motion. Something is thrown up with speed u. In what time it will reach back to its initial level? Here the acceleration due to gravity is taken as g. It's pretty simple. The time to reach back at the same level will be equal to 2u by g. Agree? Now the total angle turned by the rod in that much time will be equal to omega into t, because the angular speed is constant. And if we need the number of revolutions, it will be equal to theta divided by 2 pi. Theta is available, omega into 2u by g, and here is the 2 pi. Got it? 2 is getting cancelled out. So the number of revolutions of this rod will be equal to omega u divided by pi g. If you understood this, I'll just change the diagram little bit and bring the next version of the question for you. Till then, you can note it down. And if you have any doubt, fire up the chat box. I'll reply. So here is the next version of the question. The rod is given the u, this time making an angle theta with the horizontal. I hope you can quickly guess the answer. The previous calculations are yet valid because the net force is only the mg acting at the center of mass. So the torque about center of mass is yet 0. It means the angular velocity of the rod is yet constant. Then the calculations are again simple. After some time, the rod reaches back at its initial level. It will be going like this, as well as it will be having the rotational motion. Got it? So that time we will write as 2u sine theta by g. And the total angle turned by the rod till it reaches back at this level is omega into t, as omega is constant, and the number of revolutions made will be equal to theta divided by 2 pi. Now I am submitting the data, omega into 2u sine theta by g, and here was 2 pi. Again the 2 gets cancelled out. We have the simple relation n is equal to omega u sine theta divided by g. And eventually using this expression, we can obtain the answer of the previous question. How? Put theta is equal to 90 degree. If we consider this theta is equal to 90 degree, it becomes the previous case, and sine 90 degree becomes 1. Okay, so it was a simple and nice question. And I have another simple question for you. What if I change the sense of omega? If the omega is given in the reverse sense, will it hamper your answer? Let me know in the comment box. I hope you enjoyed the question. Stay awesome. See you again.